Hi everyone, my name is Sashi Varanasi and I lead the in-memory and blockchain specialist solutions architects at AWS. In this next 10 minutes, I'll talk about how you can cost optimize relational workloads such as Oracle, SQL Server, RDS, and Aurora workloads with in-memory caching using Amazon ElastiCache. So let's get started here. When you implement ElastiCache, a caching solution over relational databases, you can improve performance of your applications and reduce cost. According to our recent benchmarking test, you can save up to 55% in cost, gain up to 80 times faster read performance using Amazon ElastiCache with RDS for MySQL versus RDS for MySQL alone. I would like to give you a quick explanation of financial benefits of caching. When you need to scale relational databases, it gets expensive and hard to do. NoSQL databases add flexibility and scalability to your architectures. ElastiCache is a NoSQL key-value data store. It is cost-effective and has no additional fee for I/O. It can be cheaper than increasing database size, and it can scale independently of the underlying database. ElastiCache also has performance and cost optimizations within the service. For example, with enhanced I/O multiplexing, you can achieve 72% better price performance, and with data tiering, you can obtain better 60% price capacity. With ElastiCache, you are adding a layer of high availability at a low cost to your relational database architectures. We will see the benchmarking test results and examples in the slides that follow. When we say better price performance, what we mean is that, as shown in this chart, RDS cost increases linearly for nominal throughput increase, whereas for ElastiCache, the cost remains the same, as shown in the center in this chart. And throughput can increase to much higher volumes, as shown by the green line that represents ElastiCache throughput, while latency remains very low, giving you extreme performance. With one ElastiCache node, according to some of our tests, you can process a few hundreds of thousands of requests per second. To do the same without ElastiCache, just using your primary underlying database, you need a very large form of database nodes or read replicas. So what workloads are suitable for caching? Applications that are I/O bound and read-heavy applications with large volumes of data processing needs followed by frequent reads, and applications that need real-time access to large volumes of data can benefit from caching and will lower their application and database cost and improve performance. So how does ElastiCache fit into the AWS purpose-built database strategy, you might ask? One very common need is to share large quantities of data at high speeds across servers. Our customers are supporting millions of users across thousands of servers. The purpose-built strategy talks about using the right tool for the right job. In-memory databases like ElastiCache and MemoryDB solve the purpose of extreme performance of high-volume applications. Let's dive deeper into performance and cost savings that we can achieve with ElastiCache. Today, every company is digitizing their business processes and modernizing their current applications. To accommodate the scale and the size of these growing businesses, applications and databases need to scale as well to handle large volumes of data. The requirement is to not only handle high volumes of data, but also support high application performance, needing increased memory, CPU, and network capacity. Due to the complexity of the underlying architecture of relational databases, it is hard to scale out and scale back down to meet these high performance and high volume data requirements. As the data grows, the joins and the self-joins make the queries extremely complex and slow to perform too. One way we can handle the performance need in relational databases is by adding more read replicas. The addition of read replicas, though, adds to the total cost for your applications. So we need a better solution to solve this performance and the cost problems of relational databases. So how does caching help? Let me explain using this diagram. So how does caching help? When you cache, your data is not on the disk, but it is on the main memory. And because the data is in the main memory, you get predictable performance. Your performance for the reads and the writes is now in microseconds, not in milliseconds. In other words, a database cache supplements your primary database by removing unnecessary pressure on it, typically in the form of frequently accessed read data. Cache data is always stored in memory, providing that predictable, low latency performance that is 80 times faster than relational databases, and you can get extremely high throughput that can be 4 times higher. The cache nodes are much cheaper than read replicas for primary databases. We'll share the benchmarking results and data in the upcoming slides. So we talked about how we can handle performance need in relational databases by adding more read replicas. Adding read replicas is expensive. What we have done here is remove RDS read replica and provide the read capacity from Elasticache cluster. Adding a fully distributed Elasticache cluster with 6 nodes is less expensive than adding additional read replicas. Cache increases the total amount of memory available. It has dedicated network and CPU for reads and provides significantly lower latency and much higher throughput. So how do you get the database data into the cache? That is a great question to ask, but before we answer that question, what we need to keep in mind is that we are not replicating 100% of our database data in the cache. Only the results of the queries need to be cached, so there is no need to fully replicate the database. Caching is usually a more efficient method of replication for your database reads. Here are the ways we can cache the data. There are strategies that applications can implement in their code to cache the data. Let me explain the lazy loading pattern. The steps here are numbered on the slide. When clients receive a request for a data element, the first step it takes is to read that data element from the cache. If the data element is not available in cache, which is called a cache miss, it will then fetch the data from the database, in this case RDS. As a next step, it writes that response from RDS into the cache. So subsequent read requests coming to the client for that value will be read from the cache. The cache itself is a key value store, so the cache requests are based on a key. You retrieve the value of the cache object using the key. In write-through caching technique, which is another caching strategy that you can use and that is seen here on this slide, the application proactively writes to the cache while writing to the database in real time. With this technique, the cache data is always in sync with the database data, making the data consistent with the database. So now that we looked at performance advantages, cost benefits, and application implementation strategies for caching, let's review some of the benchmarking tests we completed recently that provide evidence of the data we shared so far. We did a test with RDS MySQL with its standby for an application that needs to handle 30,000 queries per second. According to our test, to meet this throughput, we need 4 RDS read replicas that costed us $1,740 per month. When we implemented Elasticache, we were able to eliminate the read replicas and instead use one Elasticache node and one Elasticache read replica node to achieve the same throughput. Eliminating RDS read replicas and implementing Elasticache costed us $780 per month, reducing the cost by 55% when compared to using RDS alone with its read replicas. With caching, the higher the throughput requirements are for your application, the higher are the cost savings. In this example, when cache is fully warmed up, which means all of your data that is read is served by Elasticache, the read capacity increased to 250,000 queries per second, and with RDS alone supporting this throughput will cost you 87% more. By implementing caching for high throughput read heavy applications, you can get significant cost savings. Alright, so how can you get started with Elasticache? Adding cache is typically a few lines of code. There is an example here on the screen that shows lazy loading implementation. You would need to carefully identify where in your application this logic needs to be added and design higher level abstractions to easily add caching to your application. We also have online self-paced learning tutorials, recorded webinars, and whole slew of resources at the links provided here. You can scan the provided QR code as well to get to these links. and we'll share this DAC as needed. Thank you for watching.